Hello. Is my audio okay?
Hey everybody, welcome to today's meeting. And Lachlan, thank you for on short notice agreeing to do your to move forward your follow-up to the Q&A session for the Trust Me Self-Verifying Remote Attestation Evidence presentation. Maybe let's wait another minute or two to let a few more folks come wandering in.
Yeah, no worries. Happy to present, and thanks for fitting me in.
All right, so let's get going here. Hour would quickly roll by, it always does. So first of all, thanks everybody for showing up today and participating. I always get a lot out of these discussions. And today we have Lachlan, who's going to um, to continue the Q&A session for the Trust Me Self-Verifying Remote Attestation Evidence presentation he gave about 4 weeks ago. Before we jump into there, a couple housekeeping things. So first, if you feel like it and get a chance, click on the link for the meeting notes and feel free to add your name to the attendee list. Second thing, um, there's, I'm not sure I recognize all the names on the current list of folks who are logged in. So if there's anybody who's relatively new to kind of joining in on these discussions would like to introduce themselves, I welcome you to do so at this time.
I'm Jesse Poole. I don't think I've ever introduced myself. Can you hear me?
Yeah, I can hear you.
Yeah, I work at Broadcom. I lead security for the VCF division.
Okay,
We're
great.
we're working on confidential computing attestation features, so figured I'd listen in.
Yeah, excellent. Welcome. Glad to have you here. Okay, so let's move on from there. One more housekeeping thing. Does anybody have any brief announcement that they want to share regarding anything related to this SIG and the space that we're involved in? Okay, so with that, let's kick it off with the planned content. And so the original planned content, Benny Fury discussing toward ownership aware attestation platform ownership endorsement was postponed at the last moment. So as I mentioned, Lachlan's agreed to jump in and continue Q&A. So Lachlan, turn it over to you now. Thank you.
Brilliant. Thank you. So I will perhaps just start just by briefly reminding you what this was about for the first 5 or so minutes, and we can maybe leave questions till after that, just so that we kind of get through it. Um, so yeah, so this is a talk that I started giving about a month ago, just after Easter, and it is about some work that I've done that I'm presenting this, but I think the real credit goes to the researchers here from Ericsson. But anyway, so the problem here is that we want to find a way to abstract over all of the different attestation protocols or attestation schemes or whatever you want to call it that we might want to use. And we have things like Verizon or Trustee and all kinds of things like that that can try to do this. They'll have a driver for each platform, and then they will verify the platform specific evidence and tell the relying party how this is and whether it matched their appraisal policy. So the problem is that this then means you have lots of different implementations in this verifier, which means that then the verifier is incentivized first not to support too many different platforms because they have to maintain it, they have to ship updates, and because it's all a monolithic piece of software, in principle, it also means that a vulnerability in one of these implementations might compromise the verifier as a whole. Because you're doing a bunch of binary parsing and things like that, and while languages and so on have gotten a lot better than they used to be, um, X509 parsing and this kind of thing has historically been a bit of a risk. So what we want to do is to allow a verifier to safely validate evidence from all kinds of platforms without having to incorporate this directly into its code. And so the basic idea is that we want to have the attester provide the verification code to the verifier. The verifier then runs that in a sandbox and then gives the output. And because we have WebAssembly, which was built for the web and is designed exactly for this use case, where you're going to download a bunch of untrustworthy code from the internet and then just run it on a machine that's handling lots of sensitive personal data. And so what we did is we took Trustee, in this case, took this platform-specific stuff that involves parsing the evidence and checking it against endorsements, and then extracting that out into a WebAssembly component that can be provided by the attester, or at least addressed by the attester. And so now there's no platform-specific code here in the modified trustee. We just have this platform-independent driver, and then this takes platform-specific evidence and a platform-specific um, policy, and and then can produce this platform agnostic output in EAR format or whatever format you want to deal with. So these slides are now updated since the last version of this talk, because we've updated some of these formats in a bit for the paper submission. But basically now we take our input in CMW format. So you take the evidence, we kind of wrap it in this format, which we're probably going to change going forward. This is all still kind of early days prototypes, and we need to perhaps rationalize some of the formats here back on. But basically, wrap this up with the verification component potentially, or a link to it, and possible collateral like certificates and so on. And then ultimately, we run through this through trustee, and we get an output EAT that includes platform-specific claims as this nested kind of nested entry here. Sorry, I realize you can't see my mouse. That includes these nested claims, but then also the identity of the verifier component. And then the idea is that you set your appraisal policy to say this is okay if the component matches the identity that we're expecting. Okay, sorry. I see in chat that you're having some problems with my
Yeah, hey,
audio.
Lachlan. You're sounding good at the moment for me. You were kind of warbling in and out a bit the last 2 minutes. I
Okay.
don't know if that's what others experience, but perhaps because some also said something. Osama, you have your hand up?
Yes, actually, thanks. I have a question regarding the overall picture that was shown. I actually don't see the slides now.
Yep.
Uh,
Sorry. Okay. This was a stupid thing. I Yeah. This was happening at the last minute, and so I was setting up my slides on the train, so I still had my laptop connected to a mobile phone that's now downstairs on the other side of the house. Um,
Well,
yeah, it was the worst possible connection. So
that'll
now it
explain it.
okay. Um, yeah. So
okay. So basically, my question is about the slide that you were showing about the attester and the verifier, right? I'm trying to understand what exactly you are saying when you say that the platform related part is shifted over to the attester side. And that's what I'm exactly this slide here. And I'm trying to understand what does this actually mean, because I'm a bit worried about this from a protocol perspective, namely that trustee, you mentioned specifically trustee, and trustee by itself is a post handshake mechanism. You do all of the handshake and you do attestation on top. I remember your answer from the last time that you are not concerned about the protocols, but what you are doing here is really related to protocol, because if you shift that part before, and that's what I'm trying to understand more. So this is probably not very helpful for me, the slides that you are showing now. So if you go back to the last slide, I'm trying to understand whether this means a tester sends some part to another verifier, get something out and then send over, or what does this verification component provided by a tester actually means? Or does it mean it has a small verifier within the attester? That's what I'm trying to understand.
So it's just a copy of the code that would otherwise be the platform driver in Trustee or Verizon or whatever. This isn't incorporated into like if you're talking about RATLS, this isn't incorporated into RATLS. This is something that's completely independent. And in the case of Trustee, as I understand, you can put the attestation service, you can directly link that into your binary by using it as a Rust crate, and then there is no actual network protocol involved here. It's just a function call on your local machine.
Uh, that's because you already established, so talking about a trustee, that's because you already have established that TLS protocol or whatever that protocol is. So that's already established. Everything is happening at the application layer. So that's why you don't
Yeah,
need to.
There's no TLS here. This is nothing to do with a tested TLS. If you're doing a tested TLS, you at some point in the protocol you're going to have something where you say verify this attestation evidence, and based on the result, you're then going to decide to go forward with that, whether you do that intra-protocol or post-handshake. This is orthogonal to this. You can run this after you've done the handshake. You can run it during the handshake. The idea is that you're taking this platform driver and the attester sends the verifier a copy of that so that the verifier doesn't have to have its own copy in advance.
So what's maybe let me try to put it in different words. So what's really confusing me is the word driver. So could you say maybe in Rat's term what the test driver mean? Is it something, does a driver mean that it verifies that evidence? What does it do to the evidence in let's say logical terms? Does it somehow convert that evidence into some attestation results or some partial attestation results or something? So this is maybe bothering me a lot because if that somehow changes it, that driver or thing that you are saying, I think then we are really not talking about this. Then I see a lot of contradiction. So I want to be first sure on what the driver is doing. Is it changing that evidence into attestation results or some partial results in
Yeah,
some
exactly.
sense?
So the driver is a piece of code inside Trustee, inside the Trustee attestation agent that will convert attestation service. Sorry, I always mix these two up, but the Trustee one, it converts the platform specific evidence into a claims map. So a list of claims that are going to be eventually used uh, to check it against some policy.
But claims are still part of the evidence. That's not attestation results. So my question, so I'm still struggling to kind of understand whether you mean, let me put it this way. So does a driver convert evidence into attestation results or not? Maybe can you say yes or no first before going forward with this discussion?
Not into a not
Claims,
into an not in the sense of EAR. It doesn't do the appraisal. It turns it into claims, and then that gives you. It basically gives a dictionary of things that will be checked against a policy and reference values.
but attester itself is untrusted, right? Part of that is untrusted. I don't understand if you it could somehow provide something to the verifier by which it could this transformation that it's doing. You're saying that it's not attestation results, but whatever transformation it's doing, that platform specific thing, converting it into, let's say, not platform specific, how is it possible that so isn't it, let me put it this way, isn't it possible that I as a tester I'm malicious? So whatever transformation you are doing, can't I do a transformation that can trick you? Let's say you are the verifier. Can't I do such a transformation that will trick you into believing that I am trustworthy while I am not? That's maybe my question here, because trust a tester by itself by definition is untrusted, right?
Yes.
Why
So
I'm
the key
depending
thing that
on.
Yeah. So the key thing is that the driver, the Trust Me driver that goes into Trustee, um, this includes a measurement of the component itself. And so now you can check this against some policy, whether it's based on the hash of that verification code that comes from the attester, or you can check it against a public key that is used to like as to sign it. Um, and then this means that all the platform specific stuff, this is now in the policy, which is meant to be changed, as opposed to the being hard coded into the verifier, which would need to be actually deployed and updated on the system. So it's turning
So
instead of deploying code, you now just have to change a policy or a reference value.
sure, that might be interesting thing, let's say from development perspective, but I see a lot of security problems that you kind of, so the summary of what I get is that you have a small verifier within the tester. And my problem is that if that is, how do I get to trust that verifier, that small that driver that you are mentioning, how do I, as a verifier, know that that driver itself is correct? You
So
said you put the measurement, but from where will I
yeah,
get the genuine measurements of that? I mean, continuing the same scenario, let's say I am an attester, I have a small verifier which is doing that driver thing. And how will you, as a real verifier, how will you get to trust the verifier that is with me? You don't trust me, and I have a small verifier. What if I trick you by having that very small verifier which is with me to make you believe that it's correct, but I keep doing whatever bad things I am doing? How will you get to trust me and get to trust the small verifier that is also in possession of me?
yeah. So the like the TEE manufacturer, for example, can distribute a CORIM manifest that's going to allow a policy to determine which is or is not um, a suitable verification component. So, in this example, we have the hash of the component itself, so the binary, and we have the public key that can be used to validate a signature on that component. And then the idea would be that you could have a CORIM manifest that gets loaded into Trustee that will validate, for example, Intel um, validation and verification components. And then later on, you decide, okay, I want to support AMD, I want to support ARM. Then you can just update the policy to have the right claims and update it and send a new CORIM file that's going to include the updated signer or component hashes. But sorry, I see also that Giri has had his hand up for quite a while.
Yeah, you didn't answer my question, but yeah, that's fine.
Yeah. Thanks. Maybe this is related. If you stay on this slide and you just look at it, and by the way, first off, I'll apologize for not attending last month's talk. Unfortunately, this meeting time has a permanent overlap with the OCP security working group, so nothing we can do about that. Sometimes I'm asked to go and attend those meetings. If I look at the evidence here, you are using a profile that's defined with respect to what Trust Me can support. At least that's what I'm interpreting with each profile, as shown in the breakout box there. Um, the thing that I'm wondering about, and I did skim through the paper, even though I couldn't attend the last your last talk. Um, that kind of had me. The thing that kept me scratching my head was what exactly is the platform in this case? Because if the attestation evidence and the profile that the attestation evidence corresponds to are all within a confidential compute container, then hardware-backed confidential compute solutions like like what AMD, Intel, or ARM CCA licensees offer can't really attest to that evidence. So they wouldn't really be providing platform evidence for in this model here. So what do you consider a platform in this in the system architecture that you're targeting, and who
Yeah, sure.
provides the evidence for that platform? Yeah, thanks.
Yeah, yeah, sure. So first, I guess I apologize for the profiles here because they are a bit of a mess because at least for me, I'm perhaps a bit new to some of these RAT standards, and so we've been kind of refining this over time. And I think this EAT part will probably be replaced by something that's pure CMW. But anyway, that's to digress a bit. So the idea is that the verifier can treat Trust Me as a platform in its own right. So it's completely independent of the hardware platform. You can take out all of the platform drivers from Trustee or from Verizon or whatever, and have something that only supports Trust Me if you really wanted to be a purist about it. And then what would happen is that you have this evidence format, and that's going to be the same for every platform. And then the idea is that the platform is going to be identified by the component, that you use to validate that evidence or to transform that evidence. So the idea is that inside here we are able to have this evidence that comes from whatever platform, whether it's SNP or something else, and then you have this component, and then what you end up with is again this trust me formatted output that's going to be the same no matter what the actual hardware is, and the link to the hardware root of trust is made by this component. So you end up with kind of like a layered attestation. So because you're running this locally and anyone can kind of repeat this verification process, uh, it's essentially, instead of being tied to the hardware by a signature, it's being tied by the component. And so what you then do is you run that component. That component makes sure that this kind of raw platform-specific evidence matches the hardware root of trust for that hardware platform, and then produces the appropriate claims. And then you can decide which actual hardware platform that corresponds to in terms of AMD or Intel or ARM, by looking at the identity of the verifier component.
Okay, so I'm going to say something here, and it may not be consistent with what you just said, so please correct me if I'm wrong. But the three platforms that I mentioned, TDX, S&P, and CCA, that are all capable of providing attestation evidence for the confidential VM specifically. So
Yeah.
that guarantees the confidentiality of the container, the memory protection of the container, etc. It
Yeah.
doesn't really say anything about what's going on inside the container because it's confidential. In this case, though, I think I'm going to interpret this to mean that the trust me profile is the evidence that should be used for the CVM attestation, and whatever hardware attestation is provided is to attest for the trust me instantiation that occurs on a particular target platform. So it looks almost like what we call internally a bare metal model, where AMD or Intel or ARM isn't expected to provide an attestation for the confidential compute container itself. It's meant to provide an attestation just for the hardware on which a platform like Trust Me would be installed. Is that correct?
So
Yeah.
I think it might be the other way around. So you're running Trust Me on the verifier side. So the attester side, the only thing that you're adding is just a library to add this wrapper here around what you would get. I'm sorry, I'm not so familiar with the with
Okay.
SNP. My
See,
terminology is a little bit wrong, but it's like on the Intel side, it would be that you would use TSM to get your raw quote, then you would wrap it in this, and then send it um, to the verifier, and then the verifier
okay,
can.
okay. So you really haven't. Okay, if that's the case, then that's good. Thank you for explaining that. I don't think you've achieved your goal of having like a common attestation format across all platforms because you're wrapping across a vendor specific across vendor specific attestation evidence that still needs to be verified, right? So whether it's you'll have you'll have a trust me profile that's wrapping an Intel TDX attestation as an example, right? So you'll still need to verify the Intel TDX evidence. You can't transcode that evidence into a trust me profile, because when you do that, I mean you'll be stripping off the signature and therefore stripping off the security guarantees. So it seems like the verifier still has to actually verify on a vendor by vendor basis some level of evidence coming from the target platform.
Right, but this is the trick. So instead of the verifier having that code that does that hard coded in, the attester can identify that either by just stapling that code directly to this attestation evidence or by providing like a URL that lets it download that from OCI. So now you end up with a layered attestation where the verifier downloads the AMD or Intel specific code to validate that evidence on demand and convert that into the standard kind of EAT type claims. It can download that on demand and then include a measurement of this code that it used to do that validation
Okay.
in the app. And so
Okay.
now you just have a policy that checks, was this validation code correct? And do the claims that came out of it match what we would expect? And we have stuff with a higher level of abstraction that we can get to later if we get that far.
Okay, but the but the WASM that you mentioned would still be would probably be vendor specific. But
Yes.
okay, got it. All right. Thank you.
Yep. But the idea is that, for example, each vendor could have its own, like, for example, you have, each vendor produces their own library to validate the attestation evidence already. And the idea is that you take this existing library, wrap it in to a WebAssembly component, and now any of the verifiers can just use this without having to add special support. Okay, Greg.
Yeah, thanks. I love this topic because it's very appropriate for some of the things we're thinking about in terms of evolving the MAA service. So it seems like the it seems like the most fundamental thing that's adding or that's creating the value here is a formal definition for breaking apart part of what I think of as the verification pipeline, and breaking out specifically like the part that's attestation evidence schema specific, right? So, and it's doing that, and it's also doing at the moment, from what I see here, it's doing that, validating that evidence is signed by the TE vendors, trusted root CA. So I'm I guess my two questions are and maybe I just need to go back and watch the presentation from 4 weeks ago or read a paper or something, but I'm very interested in the specifics of that contract, as far, as both the input and the output side here for that purple box. And if that wasn't gone into in detail last time, maybe 2-3 minutes to show something so they just get that clear in my head. And the other
Yeah,
is,
sure.
if you take to the extreme, I think maybe I'm wrong here, but let's just factor out the part that's specific to the attestation evidence. So like, for example, leaving the downstream stuff where you're just, applying COREM, COREM evaluation against an input claim set. Could you also, is it possible, did you think about like the trust decision for the evidence? Could that be genericized and done outside, or must it happen in that purple box? Right. So
Yes.
it, yeah.
So yes. So I have slides for this that I didn't get to last time. So maybe this is a good opportunity to skip over the over some stuff and talk about how you can layer more of these things on top of each other. I'll show you the interface in a second.
Okay.
Or maybe Pastor, if you're here, if you could load that into just load that up and maybe share your screen in a second, we can do that. But yeah, so one thing is that these components, because it's part of this WebAssembly ecosystem, you have these well-defined interfaces, but there's also the possibility to link them together. So you can take, two components, glue them together, and then they will show that same interface as a verification component. So from trustees' or trustees' perspective, then this is just another verifier that happens to be about a software platform rather than a TEE. And so then you could kind of completely hide the details of the underlying TEE. So kind of an example of this is, let's say you've got your components for TDX and SNP. And if you look at the claims that you get out of that, you're going to get a report body, for example, that's going to be like a nonce and whatever specific data you wanted to bind to that attestation. So now you start off with, okay, you've got your CPUs, whether it's SNP or TDX. So now, what is actually covered by that attestation? What's in the measurement registers? Well, the first thing that you're going to have is a bootloader. And in order to check anything else that comes after that, well, now you have to check that the hash of that matches, for example, in the measurement registers and in the event log. So what you could do is define new verification components that you link with that TDX one, and that's going to check the underlying TDX evidence, but then also check the measurements from the bootloader, and also the measurements that come out of the bootloader. So now your claim, instead of being just raw TDX measurement registers, it's going to be the hash of a kernel image, for example. And then you can kind of keep doing this and add more and more layers on top. You add another one that checks, okay, this is a real Linux kernel according to some list of kernels, and it makes a claim about the hash of the disk image that's being loaded. And then maybe you have one for like a confidential containers one or like a cutter one that's going to validate that this disk image corresponds to something like the cutter TDX image, and will give you claims about which container requested the attestation. Maybe you have a more complicated system where you have a GPU as well. So then maybe this will also use a verifier for a GPU as well and check some extra attestation evidence that's been bound to this one. And then that's going to still give you this container measurement, but you also know that it's connected to a real GPU. And then maybe your application has its own that can also check the reference things. And then what you end up with is a claim that says, okay, this is application X version Y. And you can check that with the verification component that comes from the application developer. And you don't have to know anything about any of the underlying platform because the application vendor, they have already decided, well, what are the correct reference values? What are the platforms we support? What is all of this, that, and that? And then as long as you trust the application developer, which you kind of already have to because you're running their code, as long as you trust them, then you can trust these claims. And so now, as a user of the resulting attestation result, you don't have to manage all of the reference values for all of the underlying things anymore. You just have to check, is this the public key of the application developer? And was this component signed by that developer? Anyway, sorry, that's long.
I think what I took away in my head here was each of these things is inputting and outputting claims. And as you go up the diagram here, the claims added by the previous layer are typically immediately used by the next layer up and produce some, further distill till you get to the app identity at the top.
Yeah,
So
exactly.
in my naive first reaction isn't this kind of similar to like how should I think of this relative to COREM endorsements, which are essentially turn the crank, full transitive closure, take all your endorsements and run the engine over and over and over until you get you get no, I call them derived claims. You get no more derived claims. And then now you have your total accumulated claim set and you decide what subset go into the attestation result token, perhaps just an app identity. So how should I think of this versus the kind of COREM full transitive closure, expand all endorsements?
So the way that I conceive of this is kind of a genericized version of that. So with COREM, you have this kind of specific you have this specific you can have this chain of specific endorsements and the application can produce that, and if that works, then that's fine. But you're also kind of limited to what can be expressed in COREM. And I think this is maybe a question that I think I would be quite keen to get some feedback in, is do you think that everything can be expressed in COREM? So to give an example of this, another thing that we were looking at is how could you do attestation of a distributed application as like a large entity as opposed to just individual TEs. And we've had stuff that we've been working on to build a protocol that will let us do this and combine attestations from individual um, like components of an application from different TEs and make sure they're all bound together. I won't go into all the details here, but then we want to um, be able to produce like a token that says, okay, well, this comes from this application that has these subcomponents all bound together. And there are potentially verification things that need to be done to make sure that all of these bindings are kind of reasonable that aren't necessarily possible just using Korean, as far as I understand. There are also cases, like for example, with when we've been looking at how to do the container um, um, measurement, there need to sometimes be transformations of these claims, and I don't think that all of these transformations can be expressed using Korean.
I'm sure we have some Codem experts here, I think, including some of the authors. Does one of them care to answer the Codem question? Because I have the same question.
Yeah, so basically, if I understand correctly, what question is how do you express composability through quorums for reference values? Is that what is the ask?
Yeah, and I think the question is, would all compositions be expressible using Korim? Or will there be times where you might want to have a kind of transformation that can't necessarily be just expressed as an endorsement?
Yeah, so we have been discussing, we're planning to discuss this item in the composite attester discussion, composites design meeting discussions we are having on the RATS working group of how to express composability in detail. But to our understanding, we have a concept called domain, which assigns aggregation of different environments to construct a hierarchical tree of environments with their measurement values, and you can construct a tree like this to express compositional semantics for reference values and endorsements.
Yeah, but this is a little different in my opinion, Yogesh, because if you look in this example here,
Yeah,
those different components don't originate from the same entity. So, for instance, if AMD is providing the S&P related quorum,
yeah,
AMD won't be able to provide the Linux kernel quorum or or going above. Um, so that's the that I think is a challenge here. I believe quorum allows for countersigning, but that may not really be practical in the kind of scenario that Lachlan is defining here, because how do you actually take a quorum and have everybody who's actually contributing to the domain sign a specific quorum and say yes,
well,
yeah,
each of these individual layers are essentially can be a part of your trust chain, right? So you need to have some kind of an identity associated with each layer, and then one platform integrator will have to assign a kind of a top level domain to say that my platform will contain these many entities, right? Somebody needs
yeah.
to take the ownership of the full composition, right?
Yeah, that's right. And that's right. And unfortunately, we didn't have the platform owner endorsement talk today. That's a solution. That's a potential solution for that. But
Yeah,
still, you have to bring in the whole infrastructure to support that, and that may not be practical in many scenarios. Particularly, what's being described here, the developer has a lot of control, right? So it's not, the developer is selecting what kind of kernel is going to be used, what kind of other code will be running on top of the kernel
yeah.
in the context of a container. So it's not easily scalable from that perspective.
Somebody needs to set that policy, right? Which on my container or on my target hardware, my container can only run on this target hardware, and
Yeah,
there should be somebody who is constructing a platform, right? Like that.
yeah,
So, so, so I believe they might have to construct quorums at the top level, which then have either location or dependent rims in their top level quorum to specify this kind of tree structure, right? So you can do it at a potentially at a quorum level, and you can also do it at a potentially at a domain level if you have the knowledge and information. But as I said, we will explore this in a bit more detail, and your use case specifically would be of quite interest to us in that discussion.
Okay, sure. Yeah, I can try to join that. I guess this will
Yeah.
I'll follow this in the reps
Yeah.
moments, I guess.
And for the multiple verifiers, there is already a work been going on, which let me post it in the link so that
Yeah, no, I've been I've seen that.
okay,
I've been meaning to post something about this in Git one of the GitHub issues, so I'll
sh-
make sure to do that.
sure. Yeah, thanks. Would love to
Yeah.
hear your feedback, and if you have any issues or if you think that there is any use case which doesn't fit the proposals or proposed collaboration or proposed interaction models, then we can certainly consider that as well.
Yeah, sure. I see
Right.
there
So,
are
so
still. Oh, sorry, please. Who was that?
uh, you can go ahead if you were answering to Yogesh, or so were you answering to Yogesh? I'm asking, are you still answering to him?
Yeah, I just spoke over someone a second ago. So,
Okay,
I
so
think
I
he
was just
completed the answer,
asking.
Usama. I think he completed
Okay,
the answer.
okay. If that's completed, then I have a related question to what Giri and Yogesh were mentioning. So first about what that was mentioned about this platform. I don't really understand what this platform here means specifically, and
Okay.
I would like to compare it with how the inter-TDX architecture works. You have, at an abstraction level, you have this CPU hardware, you have the firmware on top, you have the provisioning certification enclave, right? So then you have the trust domain coding enclave on top of that. And then you have the TDX module, which is getting the measurements from the TD, which is the trust domain. And I'm still not seeing how this architecture that you are showing and the flow that you are showing on the right is mapping over from that perspective, because you are talking a lot about attestation, and that's how the attestation architecture works today in InterDDX. And someone from Intel, please correct me if I'm wrong, because that's what we understood, and um, that's how is my understanding in the InterDDX architecture. And number one, I'm trying to understand where exactly is your boundary of the platform between all this architecture that I showed you, like the provisioning certification enclave, is it a part of the platform or not? And if that is, then there are like other questions, but what is the boundary between the architecture that I have mentioned you? Where is where, what is platform in that sense?
so that stuff is all on the attester side, and we don't touch any of that. All we're interested in is the stuff um, that is used to validate the attestation evidence. In the case of TDX, there's a nice decap QVL library that we can use, where we just put this in and then we get a list of claims. And so Trust Me doesn't need to deal with those with those parts of the architecture, except insofar as that's needed to validate the evidence. But at the architectural level for Trust Me, that that isn't
I
needed.
think so sorry to interrupt you. I think you are using uh, or maybe I should say abusing the word claims, because that's what is creating a lot of confusion. So when you're saying that it's not on the attester side, it's on the verifier side, right? And then I
Yes.
don't see why you get these claims. You don't get these claims. These are the parts of the attestation results, isn't it? Why do you say that it's generating some claims? It's not claims. Claims were generated on the attester side. They are sent over to the verifier. If you're doing everything on the verifier side, I don't see why you keep saying claims. Like, who is generating these claims? Because they were generated by a tester already. If they are verified, they are attestation results and not claims, isn't
So
it?
the claims come from the attester in a platform specific format that
Right.
that the policy engine just isn't able to deal with because it doesn't speak decap, for example. So what we're doing with the verification component is that we are taking this platform-specific format for encoding the claims, doing the validation of the crypto that's associated with that, and then transforming that into those claims into an EAT-like format that's used by trustee. And then
So
that gets fed into
is
the engine that
so
produces the ultimate appraisal result.
one very quick question. Where is provisioning certification enclave in this? Is that a part of platform verifier? Is that verified by the platform verifier or by the TDX verification? What do you say, TDX verification component?
There are
Is
no
which
enclaves on the verifier side. That's on the attester side.
but it has to verify that, right? So there are no enclaves, but there is a so there is an okay, let me try to repeat. There is the inter-TDX architecture today is that there is this provisioning certification enclave, there is this trust domain coding enclave, there is this TDX module, there is this trust domain. The verifier has to verify each of the components to correctly verify that evidence. If it's not, if you are saying that PC is not being verified, then it's completely wrong, it's broken, and that's the end of the story. All of that is not useful. What I'm saying is that when you so what I understood from you is you are saying that you are not changing a tester at all, you are changing somehow the verifier. I'm trying to understand that which part of the diagram that you were showing is containing the verification of provisioning certification enclave of Intel TDX. That's precisely my question. There were two
Oh,
blocks that you showed.
are you talking about the decap certificate chain? Like the
Not
certificate chain
necessarily.
that's used to validate the evidence?
Not necessarily the certificate chain. I mean, that's endorsement. I'm talking about something else that's claims. So there is one thing is the whole endorsement chain, and then second thing is the reference values. I'm trying to distinguish between the two. So let's not go to the certificate chain because that's a part of the endorsement side. I'm talking about the reference values. How do I ensure that the provisioning certification enclave was actually having the right measurements? It has its own measurements, it has its own SVN, security version number. How do I actually ensure that that is correct at the verifier side? So the component itself, provisioning certification enclave, is at the attested side, but something at the verifier side has to actually verify that the provisioning certification enclave itself is correct. And my question to you is, you showed two blocks in your hierarchical diagram. Is it a part of in your schema? So trust me, is it a part of that something which you called as platform verifier? Or is it the one at the real bottom that you had? I don't remember what you called it. Was it a component something XYZ? So which one of those two is actually verifying that provisioning certification enclave of Intel TDX, more specifically their measurements and SVN? So is my question clear now?
DCAT, you mentioned DCAP QVL does that.
Well, I think it's not even QVL, isn't it? Isn't it on the Intel side when you do the provisioning that
So,
the provisioning enclave authenticates itself to the Intel service, gets the kind of keys and the certification that it uses, and then QVL validates that against the certificate chain that it gets from the PCCS.
so can you go back to that figure? So where is QVL in that figure? Can you show me like the tree diagram that you had?
Yeah,
Sorry, not
it's
this one. So you had a tree diagram which you were showing before. So
yeah, it's
this
it's in
one.
here. This
Right,
box, in this
right,
box.
right. If you which box?
It's in
So
this box.
so my question specifically is it the platform verifier box or is it the TDX verification component box? Which one?
TDX.
TDX verification component box. Okay. So I think you are using the platform word incorrectly because that's what I would call as the platform verifier, the one at the real bottom. And also for the SNP, I believe it should be the same, but I won't comment on that because I'm not an expert there. But that's really very confusing terminology because what QVL is doing should be, I would call that platform verifier because that's
Well, I don't think the QVL does platform verification. It verifies the TEE stack. It doesn't verify kernel measurements, other platform components. It verifies the TDX TEE itself and the TCP components that are part of the TEE. But if you could draw a big circle around a platform and include all kinds of components that are not included in TEE.
Yeah, so I think for your like the purpose of this, you could say that this platform is Cutter. Sorry, this is terrible. This is Cutter TDX, so this is a container platform. It's not a TEE platform.
Okay. Okay, that's very helpful. Thanks very much.
So if it, yeah, I can update this in the slides.
Right. So in just to give you more context, so the way we use it in RATs is like from also from ARM perspective. So we use it for the real hardware side where we are saying like this is the for the ARM there is a similar thing. For example, there is this monitor security domain, and I forgot what HES is. So maybe someone from ARM can correct me. I think it's hardware enforced security or something like that. So when we say platform, so that kind of triggers these neurons, and so your naming did trigger that neuron. Sorry for that. Thanks.
Okay, thanks, Giri.
Thanks. Yeah, I just wanted to point something out. This is on this example here. One of the things at the bottom layer where S&P and TDX for S&P and TDX is that attestation evidence um, is generated in a high assurance part of the system on chip offering by those respective
Yeah.
companies. As you and Greg were talking about a few minutes ago about the additional claims being added as you go up in that on the right you look at as you go up for each for each of those components, that assurance for those claims is going to go down. um
Yes.
is that a consideration in the verification process in your opinion, or is that or do you think that the assurance is good enough for the attestation evidence that's being created as you go up on that right diagram?
I mean, I think to some degree it's a problem that can't really be avoided in the sense that no matter what no matter how you actually do the verification, your TCP is going to get bigger and bigger and bigger. And, the software at all of these different layers, that's all part of the TCP. And if that misbehaves, then, your attestations are all kind of worthless anyway, for anything kind of above that level, depending on exactly how those measurements are made. So I kind of agree to some degree that yeah, it is as you make this kind of more general and you encompass more and more into the TCP, then it becomes less trustworthy. But at the same time, kind of the system is what it is, and sometimes it might be that the evidence is less trustworthy, but it's because the system that you're looking at is less trustworthy, and looking at it just by looking directly at the kind of evidence directly from TDX, you could do the same thing with with COREM, for example, but you're still going to have the same problem that any of these components in your tester are going to potentially be able to cause problems.
Well, I mean, one of the things that S&P and TDX can do is that when a container is instantiated at launch, both platforms can take an accurate measurement at launch and attest to that in using high assurance hardware. Um, how important is it in your model to make runtime for the container to be runtime adjustable? For instance, to update the kernel, etc. Because every time you do that, then you have to regenerate evidence, and that's where the assurance, the security assurance of the attestation evidence goes down.
I mean, it's not important at all. If you can produce this kind of evidence with SNP, and I'm glad to know that this exists because I didn't know about this. If you can produce that kind of evidence with SNP, then you could produce a a component that would validate that and not depend on this kind of whole trail of trust in the middle.
Okay. Okay. So you're very dependent on the container launch measurements then, and you do see models where evidence doesn't need to be created during runtime for these upper components. Okay. All right. Thanks.
Yeah, I mean, it would definitely be nice to have that. But then you can also do it, you can if you can do that, then that's great. Then your evidence is more trustworthy. And you can structure verification around that so that you don't have to kind of base it on runtime measurements of this, and that probably simplifies what these components would look like as well. But ultimately, this is about how do you take some arbitrary code that will validate attestation evidence and then turn it into something that can run in any verifier. And this provides a way that you can kind of glue these things together. And if you have some nice way of doing this that doesn't depend on runtime measurements, then yeah, I mean the sky's the limit to what you can do. And you could change between that and the runtime measurement version or whatever, depending on the platform, depending on the software version, depending on whatever you want. Send this off to the verifier and it's just going to work. So if this new stuff becomes available, you can upgrade your application to do that. You can upgrade your verification component and nothing hard-coded needs to change.
Thanks, Lachlan. I'm gonna jump in here. We're 1 minute over the hour, so we've run out of time, and I suspect that we haven't drained the amount of questions we can present to you, Lachlan. I know I have a few more, so I'll let it to you whether you want to keep that an additional item on the agenda out in a few weeks to continue Q&A on this topic. At least if other folks feel we've drained it, please chime in and give that feedback. But to me, it seems like there's potentially a bit more to talk through here. So I appreciate everybody's participation today. I think we're out of time, and I think I certainly have a lot to think about myself based on these conversations.
Great. Well, yeah, thank you very much for the questions and feedback. I think this is really useful, and I'll definitely be going over the recording again to kind of see what this is. I'm available on Slack if anyone has any questions in the meantime. But yeah, if other people would like to know more, then I'm happy to keep the slot in the agenda for later.
Okay, great. Thanks, Lachlan. Thank you, everybody.
Bye. Cheers.
Thank you. Bye.
Have a great couple weeks.